Hi, everyone. I hope you can follow in English. My German is not as good as I wish, so I will do it in English. So let's start with session with boosting developer experience. It's about preview environments and monorepo. I did a talk 2 years ago at GitOpsCon that was more focused on just ArgoCD and Flux and preview environments. So it was a bit more hacky. I hope this version is more production ready, let's say. So yeah, let's go next slide. Quick introduction. So about me, you can find my blog, my GitHub handle. I'm DevOps engineer for whatever it means these days. And I work at a small startup in Berlin named Ninetailed. In the team, when I joined at least, we had one huge monorepo with all our Node.js projects. And that was everything in it. So you had infra, you had code, and we use trunk-based development. Now we still have one big monorepo, but like some repositories from on the side, let's say. About the infrastructure, it's Kubernetes. We have Cloudflare, GCP, AWS. So it's a bit of everything, I would say. And we heavily use Node.js with microservices. And about the tool itself, I guess, it's maybe the least interesting in the technical presentation, but we are a personalization tooling. We provide personalization. So yeah, let's follow. So little spoiler about your happiness during this presentation. Or I hope it will go this way. Maybe it will not be that worse, but let's see. So the first spike is now. I hope you're excited about this talk and how it's going to be. Then it's probably you are going to be a bit like, wait, let me switch tab. You're going to be a bit annoyed. Oops, a bit annoyed probably at some points with like the slides going on. And then you will discover deploy.yaml, which is a pretty exciting topic. So it's going to come pretty quickly. And then I'm going to dive into what I call ApplicationSetsception. So there are 2 slides. I hope you can like brace yourself and stay with me on these 2 slides because it's going to be quite hard. And then at the end, a lot of slides about tips and tricks. But yeah, hope you will enjoy it. Let's continue. So small introduction just about GitOps principle. In other talks, some people like cite these websites. So opengitops.dev. The 2 last one I want to focus on are pulled automatically and continuously reconciled, because that's the 2 parts that are often like misused by toolings in general. So GitOps is really when you have an agent continuously reconciling the state. And that's very important. And I will like put this slide a bit later during the presentation, but you will see why. So yeah, just keep in mind the 4 principles. Then let's go to something quite basic, an Hello World example with GitOps. So I hope everyone is familiar with this. So you have the classic. So you commit to a code repository, you build and push, right? Or your developers do at least. And then you have an automated step that commits the Docker tag back to another repository. And then ArgoCD takes care of the deployment. So the CD part is handled by ArgoCD. It's kind of classic, and it's actually one of the basics, best practice advised by ArgoCD. If you go on their documentation, you have the URL at the bottom. You can find like every reasons why you should split the code in 2 and not have everything into the code repository. But then let's see how it goes when you scale up or with a monorepo, in our case, at Ninetailed. So we have a monorepo, and when I started, we had we basically had one idea, was to keep everything inside this monorepo. So this code monorepo contained everything. We had the code, we had like some pulumi, we have basically the infrastructure and the code in the same place, which was really convenient because for developers, they have everything close by and it's easier to do changes. But then ArgoCD best practice advised to split it. And it's true, it's not convenient to have the whole, like everything in the monorepo. Why? For one reason is because we use Node.js, and Node.js reputation is quite famous, or is it infamous, about the non-modules being super heavy. Like the dependencies are crazy huge. And I'm proud of this screenshot you can see on the screen because it was after a PR reducing the non-modules. So it was way bigger before. And now we are only 8 gigabytes. So yeah, which causes the CI to be slow. So this build push git docker tag should be super fast on the normal repo, but for monorepo, it's sadly kind of slow. And if you edit some files that are like common to all your applications, it will take like ages to build and push everything. So in our case, we decided to go the route of creating another monorepo dedicated for infrastructure, where everything ArgoCD Kubernetes manifest will lies in, including the Git shard. So everything from the monorepo is committed to the other infra monorepo, let's say. Something really important that helped us in this way is to use a smart CI tools. So in our case, we use NX, which is basically a tool that detects when something gets affected and only build and push what gets affected. So especially in monorepo, you cannot just look for the folder and check if the folder was affected, because you try to split everything into different libraries and applications. So if you edit one library that is common to a lot of applications, like let's say logging, you don't want all the, you want to rebuild everything. You don't want to rebuild only the library. You want to deploy as well all your applications. Yeah, that's like basically it, and why we did like basically 2 monorepos. Then let's focus a bit more on the developer experience, because in the end, we don't care about the ops experience that much. I would say what matters is the feature velocity, the stability of your systems, and how fast can the developer push features. So from a developer point of view, what is the perfect world? So first, you want one source of truth, because you don't want to have to look in several systems to know what your application is deploying or how is configured your applications. So one folder or one file is the best to, like from a developer point of view, or one web page. I don't know how you want to format this. It should stay simple. I wish that the developers never have to touch Terraform ever, because it's a mess to debug when something goes wrong, when you have a diff, and when the apply doesn't go as expected. So I would love a YAML file, would be amazing, or at least a YAML format for like improve the development experience. And as well, I want sane defaults. So as a developer, you always want sane defaults, at least for your team. Like you define something, you say, okay, this is the base memory of all the apps. This is a base CPU. Of course, if you have one big app, you want to increase the CPU, but it should be able to create the application without having to care what are the defaults memory and CPU. You don't want to care about the probs. So health and readiness probs, you want to have defaults. The good thing with the monorepo, by the way, is you can have a library that automatically injects common probs among all your apps. So yeah, that would be the perfect sane defaults world, let's say. And then you want default alerting. So the classic risk Kubernetes, let's say, so is your application down? Did the latest deploy failed? Is your app in a crash loop? Or all these kind of alerts, or even like the memory is too high. You want all these alerts to be baked in, and you don't want to create the new alerts every time you create a new app. You want to change history as well, because it happened to us a few months ago. We had this legacy app which were using like a crazy amount of memory and some CPU, and we're like, okay, why did it use so much memory and CPU? And we never fixed like something like a memory leak, or I don't remember exactly what was the issue. But so we reduced these resources, and then 2 weeks later we had a spike, and the app was stuck in a crash loop, and that's why we learned why the memory was so high. And for this app, we didn't have any change history, which was an issue. And the last 3 ones, so change approval and review. So you always want, for production changes, to have someone checking what you did. A typo happens so fast, right? Especially when you debug an incident, you want to do a change and be reviewed by either your manager or a coworker or someone with production experience. A single pane of glass is a classic as well, because you don't want to check the logs in one tool and the metrics in another tool and whatever traces in yet another tool and your deployments in another. You want everything in one place. That's way easier to know when something goes bad. Let's say it's easier to know, like to debug. And last but not least, perfect transition to the next slide. The infra config code should be close to the application code. So at our first iteration of monorepo, I will say we always wanted to keep things close by. That's why everything was in one monorepo, but it goes against best practice, right? So we have 2 monorepos. So eventually, the best idea we got was to have one file close to the application code that configured the infra for the developer. So let's see how it looks. So let's say this is the tree structure of our monorepos for the code monorepo. And you have several applications. So you have an API, another API, and a scheduler. What would be the best is to have a deploy.yaml file. And now it rings a bell maybe from earlier with the graph, the happiness graph, I hope. So you have your deploy.yaml file, and this should be the best for the developer to just configure whatever they need. So they should just have to create one file, and the application should be automatically handled like build, push, deploy with same defaults and everything. So how would the deploy.yaml looks like? This is an example of a simple API deploy.yaml. So in that case, you only need technically 4 lines for an API. I mean, you could remove the container in the ports, but I don't think having an API without a port is super useful, except if like you only communicate with a queue. So it could be even simpler with like 2 lines, but you basically need 2 things. First, you need the app name to define a name for your app. And the second one is what kind of helm charts do you want? So you can see this charts folder as an internal service catalog with like custom helm chart for the team. And then they can just pick whatever they want. So another example of helm chart they could use is a cron job service. So here, first one, you have an HTTP service for any kind of API. And the second one, you have a cron job service to run any kind of cron jobs. But then you're telling me, okay, it's pretty simple, but what if I want to change the liveness of this HTTP service? Because I'm deploying an application where I don't have control on the liveness. I cannot use a standard library the team builds. Or let's say, okay, I need rate limiting on this one. I need to expose it to the outside. I need to configure the subdomain, whatever. Well, you can, because I mean, it probably looks familiar to you, but it's basically a kind of like a values.yaml for helm charts. So you can customize everything you want inside of it. So in our case, we have everything. We have basic security defaults, but you can override them if you need. Some of them you can't for security reasons, obviously. But you can still increase memory, increase CPU. And the good thing as well is for memory and CPU, for example, if you just have to check the history of this file in Git, and then you get to know why it was changed. But you don't have to go to the infra repo. You stay in this code repo, so developers monorepo, which makes it pretty convenient and efficient, let's say. So yeah, if we come back to our happiness graph, we are exactly at this level. So at the spike here of the deploy.yaml, so everything seems perfect. I showed you with one file, you can make your developer happy. You're probably wondering right now, okay, how does it work? How do you have this deploy.yaml? How is it linked to preview environments? So yeah, let's check. So 2 things that are really important to understand for the following of this talk is application sets with ArgoCD and multi-sources. So let's start with application sets. So in the past, ArgoCD had this way of deploying applications with applications. So they have an Appset-of-Appsets pattern where they will just deploy in applications that targets a helm chart, and this helm chart contains other applications. So you could have an application named infrastructure, and inside this infrastructure, you have an application deploying Prometheus helm charts and another one deploying cube state matrix, or I don't know, Crossplane, whatever. And they replaced it, or they introduced a new concept of application sets, where you can loop through anything which is provided by Argo. So it could be you can loop through files, you can loop through folders, pull requests, or list, for example, and you deploy one application for each item of this loop. So for a list generator, you provide a list to Argo, and Argo basically just deploys whatever is in this list. So you could say you could have in your list different clusters, you could have different application names or whatever, and give it some parameters, and Argo takes care of deploying applications. So if in your list of this application set you give 10 applications, Argo will deploy 10 applications. But the one we really care about in this slide is the Git files generator. So to come back to our infra repository and code monorepo, the idea of these Git files is ArgoCD, when you create your application set, will look at all the deploy.yaml files inside your monorepo and deploy one application for each of these deploy.yaml, which makes it really convenient because you have all your applications in this folder. So you just have to tell Argo, look into apps folder and try to find any deploy.yaml file and deploy it. and you can deploy applications in your cluster. That's as easy as it is. And the second important point is the multi-sources. So it's a beta feature. I should have put a warning probably in this slide. So what is multi-sources? Usually when you deploy a helm chart with ArgoCD, you can only deploy the values.yaml that belongs in the same repository as the helm chart. But with multi-sources, what you can say is to tell your ArgoCD definition. So in the application set, you can tell application set or application. You can basically indicate Argo to point to a helm chart in a repo. So for example, in the infra repo, and you can point to another repo like the code repo for any config.yaml or deploy.yaml. So you can split your configuration in two parts. You can happen values on top of a helm chart. In that case, you probably start to do connections. The helm chart is the internal charts provided by in the infra repository. And the config.yaml comes from the code repository, and the developer takes care of it. So in green, you have developer responsibilities, kind of, and in blue, you have ops responsibilities. Yeah, let's continue with an example of production. So when you combine the Git file generator and the multi-sources, you end up with what I kind of said earlier. You loop through every deploy.yaml that you can see on the right. And then in this deploy.yaml, you can specify what kind of helm charts do you want. So you will just write, okay, for my API, I want an HTTP service. And then ArgoCD picks the HTTP service from the infra repo, combines it to the deploy.yaml, and creates your application. Same for the other deploy.yaml. ArgoCD picks, I don't know, if in this deploy.yaml, it indicates something else, like cron job service, it will deploy a cron job service or an API or whatever the developers can. So in the end, the developer just have to take care of one deploy.yaml file, indicates what service they want to deploy. Is it a HTTP or cron job or something else like a Redis or a Postgres? But what we've noticed so far is two helm charts are really useful. HTTP for any HTTP service, and cron job for any cron job service. And that's basically it. Redis, Postgres, etc. is for most like infra under the hood. But for application, it's enough. It's just basically enough, HTTP and cron job. And even for applications that are not HTTP services, like imagine you have your application that listens on messages from a queue. Then you don't need HTTP technically, but you still want HTTP to have liveness and readiness probe. So you can deploy this application with a HTTP service chart because it's still HTTP, even though it communicates with other services without using the standard API. Yep, basically that's it. How will it work for staging? It will be exactly the same. You will create another application set, not for production, but for staging. And it will just work the same. You can just target another cluster or target a different namespace like staging, and it will work. But then you might see an issue with this. With a monorepo, you don't want to push everything to staging. It will probably conflict between the different pull requests, and it's probably getting messy quite fast. So that's where the preview environment fits. So for preview environments, I hope everyone is kind of similar with the concept, but basically for each pull request, you create a separate environment. And that's it, basically. So why is it useful? Quickly, because you can test changes in isolation. A classic example are database migrations. Because when you do migrations, you don't want, for example, that one PR is breaking staging with some wrong migrations, but another PR is doing migrations as well, and then you cannot push a branch if the other one is still not ready. So it gets messy. While with preview, you have a dedicated database for each preview, and so you can do whatever migrations you want in the order you want, and it just works. As well, as you can see here, you can share at any point of the workflow a URL with your coworkers, and they get to see the live environments in isolation. So if you do front-end changes, it's pretty cool because then you can just submit this new nice button to your, I don't know, the QA or the designers or whatever. And last one, but not least, the test infrastructure. It's so useful to test like some infrastructure changes, but you don't want to break common staging. So you can just tweak the infrastructure for this preview and then merge it back to main. That will affect and then update the infrastructure for all the other applications. And that's, I think, the main use case we currently use it, because it's so useful to avoid breaking production. It's basically it. Let's go next slide. And talking about pull request preview environments and pull requests, ArgoCD has a pull request generator. So if you don't have a monorepo, but it would be weird to watch this talk if you don't use a monorepo, you can still learn from it though. The pull request generator is enough probably for your use case. So let's see quickly how it works. So same behavior, you have a code repository, you build and push, you commit the Docker tag back to the infra repo, and then ArgoCD basically loops through all the open pull requests and deploys a namespace per pull request. That's the easy gist of it, I would say. But it won't work so well with a monorepo, because you don't want to deploy one application, right? We still want to deploy several applications in the same repo. So how would it work? Well, a kind of a naive approach, I would say, is to use another generator that I kept silent so far. It's the ArgoCD matrix generator. So if you're not used to matrix generator, it's basically combining several generators together. So if you have a list generator and a cluster generator, and the list is the number of environments, it will deploy to, it will do a matrix of the list and the clusters and deploy to each of them. And in our case, we have PR generator and Git file generators. And that's what seems the easiest, because for our monorepo, we use Git files generator to deploy every deploy.yaml. And then you can do this for every open PRs. But a question we have then is, what do you do and how do you do with common resources? So let's open this. So with common resources, like if you want one namespace shared by everyone, if you want like some Docker registry, for example, created outside of Kubernetes to store your Docker containers for this pull request, or if you want a common ArgoCD project just for one PR, so your developers, when they are on the ArgoCD UI, they can just click, the drop down and filter by project. Well, all these resources should be created in the common space. But here, they are basically it creates one application, a standalone application for each deploy.yaml and each pull request. So it's kind of annoying. You cannot really deploy all these common resources. You can think about different other resources. I don't know. It could be a Sentry project or any kind of controllers or operator resources. So custom resources, anything shared to your preview environment. So that's a big no for preview environments, which comes to a title that you might be familiar with, because I already talked about it earlier, the ApplicationSetsception. Hard to say. If you think about it, it's the same. It's kind of the same as saying Appset-of-Appsets. I told you about the Appset-of-Appsets pattern. This one could be ApplicationSets. So how would it work? So for each PR that you can find on your Git system, ArgoCD will basically listen on each pull request open and create an application for each pull request open. And in this application, you can deploy other resources, right? So usually a deployment.yaml and all this kind of stuff. But instead of doing a simple deployment.yaml, you will replace it by another ArgoCD application, which will be a Git file generator. And along this, you can put the namespace, whatever, the ECR, the Docker registry, any common resources. So you end up with two ArgoCD application sets. You have your PR generator that takes care of listing all the PRs and deploying one preview application, let's call it, one application PR 1898. And this application contains the namespace, the ECR, and other commands, plus an application set that is going to deploy all your deploy.yaml. So I hope it's not too weird so far, but it's going to be worse. So stick with me. That's basically it. So every deploy.yaml will be deployed as an application deployed by this Git file generator, which is deployed by this application, the first application sets, the PR generator. Okay, that's a lot of a nice diagram, but how does it look like YAML-wise? Yeah, that's a meme I had to add because be ready. This is how it looks for the first application sets. So if you're not familiar with application sets, it's a template for an application. So we enable Go templating. We loop so all the pull requests in my monorepo or in the code monorepo. We give it a unique name, so we add the PR number. So from every generator, you can get some parameters. So in that case, you can get the PR number as a parameter and the branch log as a parameter, which is pretty useful. And I'm going to say more about it later in the slides at the end with the tips and tricks. But basically, you have this application set, and the really important part is the generator pull request. So it creates one application for each pull request, and the application being deployed is a custom helm chart called preview charts. Yeah, surprise. And this preview chart contains what I showed earlier. It's basically another application that I can show you that contains another application set. And this application set takes care of deploying the deploy.yaml files. It's ugly, right? But so you have two folders. You have in one folder this application set that deploys your pull request, and in another one you have your common resources and this application set that creates an application for each deploy.yaml in your monorepo. And because you can use these arguments from the first application set, so you get the PR number, the header of the PR, the branch name, well, you can basically target the revision of your branch, which is pretty cool because then it means that if you do any change to your deploy.yaml, you don't need to commit back to main and be really noisy. You can do changes on your deploy.yaml, test it on your preview, because the preview will reflect any change to this deploy.yaml on this branch. And then when you're ready to merge to main, the production application will be updated. So it's a pretty neat workflow, but it looks kind of horrible. And in the end, this deploy.yaml that you can see here, that gets looped on. You can see it could be as simple as this, like I said earlier. So you get all this deploy.yaml that deploys a different application. And that's probably the moment where you decide to stop anything related to ops and start to do CSS and front end. But no, stay with me. Let's go back to our happiness graph. We are at the bottom of it, so now it can only go up. That was the worst moment I would say of this talk. So let's see what's next. One big reminder: it's not about great DevOps experience. It's not about great. I mean, yes, it's great DevOps experience, but it's not great ops experience. It's not great. I don't know, system admin experience. It's great developer experience. So from a developer point of view, they have one file to take care about. They care only about one file, which is amazing for them. You don't have any bottleneck. They can create application by themselves because they just create a new application. They add their deploy.yaml, and they have out-of-the-box preview environments, production environment. They can I don't know, if they have a manager that can review their pull request, they can edit anything memory-wise and have like comment directly on the pull requests, why they increase the memory, why they need the right limits, what subdomain they use to expose the application. And the last that I really liked, there is no ClickOps. So ClickOps is really, really good. If you have experience with Terraform, you know how painful it is to set up. So for the first day, so as people say, the day one operations, ClickOps is amazing because you can get started quickly and everything. But for day two, it's painful. So this solution allows great day two operation because once the application sets are set up and everything works, it's easy to get going, and you have this deploy.yaml, and it just works. You don't wonder why something changed at some points. Everything is in Git. Everything follows gitops. It works just great. And in the end, we only use Grafana, the Grafana suite, the Grafana tools, basically. So Grafana, Prometheus, Loki, etc. under the hood. So from the developer point of view, they have everything on Grafana. They don't even need to log into ArgoCD to see what happens because everything is in Grafana. So ArgoCD and kubectl is more for break a glass tool, kind of, that you still have with this solution. Yeah, time to go inside our how will you say, a new arc of this presentation, tips and tricks. So random slides about ArgoCD, monorepos, and some stuff that we learned on the way. Still have 15 minutes left, so pretty good. So the first concept is related to these deploy.yaml files. So when you have these multi-sources, you can specify different sources. So your first repo, your infra repo, and your second repo where you are getting the values from. But what's really interesting is inside the value files of your Helm chart, you can build some layers. The first layer will be the default values from your Helm chart. So if you provide a HTTP Helm chart to your developers, inside of this, you have default values that are common for everything. Default would be disable ingress, set low memory, set low CPU. And then what you could do is have another file, values.production.yaml, that says that, for example, a minimum replicas is always 2. And so you are sure that all your applications that are deployed for production will have minimum replicas 2. And you can have all the rest, like you give more memory, more CPU, maybe you schedule them on better nodes. I don't know. You can tweak it whatever you want to be production ready. Same with preview environments. For our for application set for previews, we have a values.preview that makes sure in preview environments you run with low CPU, low memory, and only one replica, so it doesn't cost too much. But then this path of the path variable is basically injecting the path to the other repo. So in that case, we are using the git sha. So this production slash values is the git sha of our application. But the two last ones are the very interesting ones. The deploy.yaml is the one in our code monorepo. So the deploy.yaml that I just talked about it for the last 15 minutes. And the second one is a file that can be added. So it's an optional file to override values for developers. So imagine the developer still wants to deploy the YAML that runs, I don't know, with more memory than usual for preview, because it's a big application. You will set in deploy.yaml 300 megabytes memory. But let's say for production, you notice you need way more because the traffic is way more intensive. You can override this memory, these resources, inside the deploy.production.yaml. So from a developer point of view, actually, that's pretty that's similar to what NX provides. They have this kind of waterfall, and NX is our monorepo tooling. But basically, from developer point of view, they have deploy.yaml, source of truth, and on top of this, you have some overrides. So you can add some custom values for production. So on the right, you just see the developer point of view, which is super neat because they can override by themselves their values per environment. So if you have a staging, you could have a deploy.staging.yaml, which will override just for staging. Yep, that's pretty cool. Second one, about the generator parameters. So quick learning, I would say. So once someone created a branch that they manually created with like git checkout -b, they didn't use Jira to create the branch name. And they had weird characters in their branch name, which caused the applications to break. Because for preview environments, we use the branch name in the application name. So something you can use in, actually it's coming from ArgoCD, is the parameters in the parameters of these generators have a version that often is called like normalized or slug, or I don't know, something that is a variant of the default parameter, but is safe to use with Kubernetes. So it will be truncated. It will be conformed to the DNS, like the DNS format for Kubernetes. So I think it's truncated, lowercase, and replace every weird character with dashes, which is really, really useful to create safe names. You don't need to like do even worse templating with like add your own truncate function and stuff. You can just use the parameters provided by Argo. Link below if you need to learn more about it. Then, classic, the commit spam effect. So if you remember from what I said earlier, so earlier, I mean the first slide, we are talking about gitops. So gitops, you need to have a version state. But for preview environments, do you want something versions? Because if you store the git hash of every app inside the folder, you end up with one file per environment per app, which is fine because you don't often have thousands of applications. Maybe some of you do as well, but usually it's kind of manageable. If you have thousands of applications, you have thousands of files, fair. But what if you have like several pull requests, and each pull request is creating a new file. How do you clean them up? How do you manage these files? So it gets kind of dirty, right? And it goes against, I mean, it goes towards the GitOps principles, but I feel like for preview environments, you don't want it to be immutable. You want to remove that part from GitOps. Because with preview, you want something that it still has kind of some randomness, let's say. So in that case, what you can use is a headshot parameter that comes from the pull request generator in the container image tag. So when you are building your Docker image for a preview environment, you use the headshot of the git shard basically of the head of the branch to tag your Docker image. And inside the helm chart, when you deploy it, you set this headshot to be the parameter given by the application set from Argo, which has great pre-value. But something annoying is when you have a heavy, like I said, 100 modules, and your CI takes ages to build because, I don't know, someone changed a file that was needed for several applications, and then you have 15 applications rebuilding. Well, you can hit the limit, which is 5 minutes on Kubernetes. When you have your deployment trying to pull the images, it will try to pull the image for 5 minutes. Then it's stuck and you need to retry to a new deployment. And you cannot change, as far as I know, these limits. So for preview, the best would be to set something really high, like 1 hour, and then eventually the CI will finish and you can pull the Docker image, start a deployment. So one solution we found for this is to add a script, but only when it's a preview environment. So we have a condition that says if it's a preview environment, you add a small init container that pings the ECR. So in that case, we use AWS, but it could be anything, where you ping to make sure is the image here or not. And basically, the container won't do anything and just wait before pulling the image, which solves this commit spam effect, because if you think about it, you don't need to commit back for every preview, every applications. You just do it for static environments, static like staging or production. That's it for the commit spam effects. Then another great tips, if you don't know about Cloudflare tunnels, they are just amazing. Why? Because you can provide access under authentication, like secure authentication with Google. I mean, you can use Google or whatever provider you use, but you basically get access with this to like a protected endpoint for Argo and for whatever you deploy in your preview environment. So let's say you deploy an internal dashboard. Well, you can make it available for previews with like secure access only to your team, because you can configure these tunnels to be, for example, only allowed for your email addresses or your company or your developer group or whatever. Yeah, another slide, some branch gymnastic between repos. So you have infra monorepo and dev monorepo here. So something that should be, I think, specified is imagine you want from your deploy.yaml to test something, like to test a branch, like no, let's set it differently. So imagine you have your HTTP helm chart where you are configuring for all your apps, but you don't version it. You just use head. So the latest state is what should be deployed. Well, in that case, sometimes you want to update it. So for example, to add some options. So you forgot the security context for your pods, and you want to add this security context. Well, now you have a branch on this infra repo, and this branch contains the security updates, right? So on the dev monorepo, you could create a pull request that changes the deploy.yaml, or any deploy.yaml, or all the deploy.yaml to target this new branch. So it means from your deploy.yaml, you can test a change that was done on the infra monorepo. Because one thing that is really hard with this kind of setup is to do a local testing. So in that case, you could create your pull request, do a small change. You think it won't break anything, but you still want to test. Specify the target branch, and then you discard the pull request. You don't need to merge it back to main. And this will make sure that your changes on helm charts are tested in preview. So in an environment similar to production. And another one, a big one. So we ended up with a lot of resources that were not cleaned up in AWS. something to learn when you deploy databases like Postgres. Let's say you use the Bitnami Helm charts. Well, by default, they don't clean the volumes. So if you delete the Helm chart and the namespace, so you let Argo clean up everything once a PR is merged, you will end up with a lot of volumes open. So something to keep in mind, think about disabling them in preview environment. And it works for any kind of previews, not only about Argo. If you build your own system, disable long-term storage for your preview environments. And last slide, it's basically the last slide of this talk. So let's keep in mind about the pain points. So it takes time to build. There are a lot of learnings out of it. Everything you need to basically, some small bugs, some small fixes, some small stuff that will steal your time along the way. So it's homemade. You've seen the init script that wait for the containers. You've seen like some disabling the PVC. So it's not out of the box. It's hard for ops folks as well. So if you remember this application set of application sets, this ApplicationSetsception, if you have a new joiner, it's hard to explain. It's hard to reproduce in local as well. Application sets with like involving stuff like Crossplane, it's painful. It's hard to reproduce. It's hard to test as well when you do a change. So hopefully with this deploy.yaml and targeting the other branch from the other repo, it helps to ease the pain, but it's still painful. And it's hard to read for ops, because with application sets, you target something that doesn't exist yet still. I mean, it doesn't exist all the time. So when you target pull requests, and then you don't really know what you have available, it's basically hard to code. But everything to say, keep in mind the slides about the great developer experience. Everything is about the developer experience. So this setup makes it super easy for developers to create applications, to update applications, to have reviews from their peers, to just change stuff, deploy stuff. And they have, now I think you say you have a service catalog, right? Well, our service catalog is our Helm charts, the few Helm charts we give them, and then they can use them in whatever they want. And these Helm charts have basic security. They inject our own secrets into them. So you have, like from developer point of view, you have a super neat experience. From the ops point of view, it's not that neat, but in the end, once it's set up, it's nice. And I think I can end on this slide and this. Hopefully I didn't forget anything. It's probably the question time, and right on time, I think 2 minutes. Yep.